The National Electrical Code, specifically the 2002 edition, addresses the number of outlets that can be fed downstream from a ground fault circuit interrupter, or GFCI, receptacle. Section 210.8A3 of the NEC 2002 stipulates that a GFCI receptacle should not supply more than 3 or 4 additional outlets. This limitation is in place to ensure the effectiveness of the GFCI protection and to prevent nuisance tripping. Understanding this code requirement is crucial for electrical installations to maintain safety and code compliance. The purpose of a GFCI is to protect people from electrical shock. It does this by monitoring the current flowing to and from an appliance or device. If there's a difference of as little as 5 mA between the outgoing and returning current, indicating a leakage of current to ground, the GFCI trips and cuts off the power. This happens very quickly, typically within a fraction of a second, which can prevent serious injury or death. Section 210.8 of the NEC covers ground fault circuit interrupter protection for personnel. Subsection outlines specific locations where GFCI protection is required. Paragraph 3 within this section provides details on the number of outlets that can be supplied. Specifically, it states that not more than a certain number of outlets can be fed from a single GFCI device. The specific number is either 3 or 4. Depending on the interpretation and the context of the installation, it is crucial to consult the specific edition of the NEC being enforced in your jurisdiction, as codes can change over time. Limiting the number of downstream outlets from a GFCI is important for several reasons. Firstly, it ensures that the GFCI can effectively detect and interrupt ground faults. Each additional outlet adds to the potential for current leakage. If too many outlets are connected, the cumulative leakage current might exceed the GFCI's tripping threshold, causing it to trip unnecessarily, or worse, masking a dangerous ground fault condition. Secondly, limiting the number of outlets helps to isolate the source of a ground fault. If a GFCI trips, it can be difficult to determine which of the connected devices is causing the problem. By limiting the number of outlets, it becomes easier to troubleshoot and identify the faulty device. Thirdly, it enhances the reliability of the GFCI protection. The more outlets connected to a GFCI, the higher the load in the device. This can lead to increased wear and tear, and potentially reduce the lifespan of the GFCI. Furthermore, a heavily loaded GFCI might be more susceptible to failure in the event of a surge or other electrical disturbance. In a typical residential setting, GFCI protection is required in areas where water is present, such as bathrooms, kitchens, garages, and outdoor locations. In these areas, it is common to find multiple outlets that could potentially be fed from a single GFCI. However, it is important to adhere to the NEC limitations on the number of downstream outlets to ensure proper protection. There are several ways to comply with the NEC requirements for GFCI protection. Firstly, you can use individual GFCI receptacles at each outlet location. This provides the most comprehensive protection, as each outlet is independently protected against ground faults. Secondly, you can use a GFCI circuit breaker to protect the entire circuit. This is a cost-effective solution for protecting multiple outlets, but it's important to ensure that the circuit is not overloaded and that the GFCI breaker is properly sized for the load. Thirdly, you can use a combination of GFCI receptacles and standard receptacles, ensuring that no more than the allowed number of downstream outlets are connected to each GFCI receptacle. When installing GFCI protection, it's important to follow the manufacturer's instructions and to test the GFCI regularly to ensure that it's functioning properly. The NEC provides detailed guidelines for the installation and testing of GFCI devices, and it's important to consult these guidelines to ensure compliance. In addition to the NEC, local building codes may also have requirements for GFCI protection. It's important to check with your local building department to determine the specific requirements in your area. It is also important to understand the different types of GFCI devices available. GFCI receptacles are designed to be installed in place of standard receptacles, providing ground fault protection at the point of use. GFCI circuit breakers are installed in the electrical panel and protect the entire circuit. Portable GFCI devices are also available, which can be plugged into standard outlets to provide temporary GFCI protection. When selecting a GFCI device, it's important to choose one that is appropriate for the application. GFCI receptacles are typically used in residential settings, while GFCI circuit breakers are more common in commercial and industrial settings. Portable GFCI devices are useful for temporary applications such as construction sites. Regular testing of GFCI devices is essential to ensure that they are functioning properly. The NEC requires that GFCI devices be tested at least once a month. This can be done by pressing the test button on the GFCI device. If the device trips, it is functioning properly. If the device does not trip, it should be replaced immediately. In addition to monthly testing, GFCI devices should also be tested after any electrical work is performed. This ensures that the wiring is correct and that the GFCI device is properly installed. It's important to note that GFCI devices are not a substitute for proper grounding. Grounding provides a path for fault current to flow back to the source, which helps to prevent electrical shock. GFCI devices protect against ground faults, but they do not protect against other types of electrical hazards, such as short circuits or overloads. Therefore, it's important to ensure that all electrical circuits are properly grounded and protected by overcurrent protection devices, such as circuit breakers or fuses. When working with electricity, it's important to take precautions to protect yourself from electrical shock. Firstly, always turn off the power to the circuit before working on it. Secondly, use insulated tools and equipment. Thirdly, avoid working in wet or damp conditions. Fourthly, never touch bare wires or terminals. Finally, if you're not comfortable working with electricity, hire a qualified electrician. Ground fault circuit interrupters are important safety devices that can help to prevent electrical shock. By understanding the NEC requirements for GFCI protection and by following proper installation and testing procedures, you can help to ensure the safety of yourself and others. It's also important to be aware of the limitations of GFCI devices. They do not protect against all types of electrical hazards, and they should not be used as a substitute for proper grounding and overcurrent protection. If you have any questions about GFCI protection, consult a qualified electrician. They can help you to determine the best way to protect your home or business from electrical hazards. Remember that electrical codes and regulations are constantly evolving. Stay updated with the latest changes to the NEC and local building codes to ensure compliance and maintain the highest level of safety. In conclusion, understanding the NEC 2002 Code Section 210.8 A3 and its limitations on the number of outlets that can be fed from a GFCI receptacle is crucial for ensuring electrical safety. By adhering to these guidelines, you can help to prevent electrical shock and maintain a safe electrical environment. Always prioritize safety and consult with qualified professionals when dealing with electrical installations.